So we went through, we found ones where the derivative was given to us or we were already given an equation to work with. This time, all we are given is our starting equation k of x. So let k of x equal to x squared plus 5x minus 3. Write the equation of the line tangent to k of x when x is equal to 3. So we need our two things. We need a slope and a point. So let's start with our point. So we're plugging in a value of 3. So we are finding k of 3. So we plug 3 in for all of our x values. 3 squared is 9. 5 times 3 is 15. And we subtract 3. So if I combine all of those together, that gives me 21. Okay, so 321 is my point. So if I want to, I can already go ahead and do y minus 21 is equal to blank times x minus 3. And now I just need to put my slope in once I find it. So for our slope, I'm looking at x equaling 3 of this equation. So we're going to use when it's at a specific point and see what we can get. So I'm going to use the one where it was our x, as x approaches a, so that way we can kind of see it in a couple different ways. So I have the limit as x approaches 3 of our function f of x. So x squared plus 5x minus 3. And we are going to subtract f of a. So in our case, f of a is our k of 3 that we found, which was 21. In the denominator, we have x minus our a value, which our a value in this case is 3. So if I were to plug this in as is, it's going to give me 0 over 0, which means I need to try something else. So what I'm going to do is try to simplify the top and then try to factor it to see if x minus 3 is a factor that I can cancel out. So the limit as x approaches 3 of x squared plus 5x minus 3 minus 21 should give us minus 24. Okay, so we're going to leave the denominator. We have x minus 3. In the numerator, I have an x and an x. To multiply to get to negative 24 and add to get to positive 5. So my bigger number is going to be positive. My smaller number is going to be negative. When I look at this, 8 times negative 3 gives me negative 24, and 8 minus 3 gives me 5. So this is my factors. So what I'm going to do now is cancel out that common term, so divide out the x minus 3, which then makes it so I have the limit as x approaches 3 of x plus 8. If I go ahead and use direct substitution, we are now doing 3 plus 8. 3 plus 8 should give me 11. So now I know my slope is 11. So I'm going to go ahead and just pull that in here. So we could absolutely do it this way. With the factoring method, it's really not that bad because I just needed to simplify and then factor it. It's kind of stuff that we practiced last unit, kind of using that information to help us out. Okay, but we have other ways that we can do it. So let's look at another way for how we might do this. And for this one, we're going to look at what it would look like for doing any function. So if I wanted to look at more than just x equals 3, we are going to look at what that would be. So we would do the same thing to start out with, k of 3, but we already know that that is going to equal to 21, so I'm not going to worry too much about showing that again. So what we're going to use now is the limit definition of a derivative. So we have f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So this is our limit as h approaches 0 of our difference quotient. So now what I'm going to do is try to plug everything that I can in. One thing you're going to notice is that I write limit a lot, and that's because we don't get rid of the limit notation until we use it. So I now have the limit as h approaches 0 of, I need to plug f of x plus h into my function. So this first part is just f of x plus h. So I have x plus h squared plus 5 x plus h minus 3. I also need to subtract f of x, so I'm just going to write everything that we have here. X squared plus 5x minus 3. This is all being divided by h. Okay, so now what I'm going to do is I'm going to try to expand the stuff that I can expand and simplify the stuff that I can simplify. So I have the limit as h approaches 0 of x times x is x squared. X times h, which happens twice, gives me xh, so I'm going to have 2xh. And h times h is h squared. I have 5 times x, 5 times h, minus 3. When we get over here, one of the things that we need to remind ourselves is we are subtracting everything from f of x, or everything in f of x from the other piece. So this subtraction is going to be distributed to everything. So everything's sign is going to flip. So we have a minus x squared, a minus 5x, and a plus 3. The limit as h approaches 0. Okay, so now when we look in here, I have a positive x squared and I have a negative x squared, so I'm going to go ahead and cancel out those two things. They make a 0. We have a 5x that's positive and a 5x that's negative, so I'm going to go ahead and cancel those two out. And our final thing, we have a negative 3 and a positive 3, so if we were to add all of those together, they will 0 each other out. We're going to write what's left over, so I have a 2xh and an h squared. Okay, so the limit as h approaches 0. If I were to plug in 0 for h as is, I have enough stuff on top and bottom that it'll still be 0 over 0. So what I need to do is I need to try to get rid of the h in the denominator. So when I look at the numerator, we have a 2xh and an h squared. They both have an h in common, so I'm going to pull out an h from everything in the top. When I do that, I'm left with 2x plus h. So h times 2x giving me the 2xh, h times h giving me the h squared. Now that I've done that, I can go ahead and divide out those h's. And I have 2x plus h. I am now at the point where I can go ahead and... Oh no! I've made the unfortunate pitfall of forgetting one of my terms. We have a 5h here. So I'm going to add 5h into this. The only thing that changes is right here, instead of having a plus h by itself here, I also have a plus 5. Okay, now that I've made sure to rewrite everything and we have our limit as h approaches 0, we can go ahead and apply it. So the thing that we need to remind ourselves is that we are replacing h with 0. We are not replacing any other variable with anything else. So 2x, even though x is a variable, is going to stay as 2x. I'm plugging in 0 for h, and that's it. So I have 2x plus 5. So f prime of x equals 2x plus 5. Now that I know what my derivative is, I can go ahead and plug in 3. So f prime of 3 equals 2 times 3 plus 5, which gives us 6 plus 5, or 11. So we get the same thing, but this gives us something that we can use for any number, not just our value of 3. But on the other hand, it does take a lot more effort. So it really just depends on what we need. If I need to plug in a bunch of numbers, having to simplify it and factor every time sounds awful. On the other hand, if I only have one number to plug in, this seems a lot easier and faster than doing this every time. So we're going to have ways that when we look at stuff, it's kind of like a pick and choose on what we want to do. So thank you for watching, and don't forget to like and subscribe.